NASA and the European Space Agency (ESA) have provided exciting new images of the interstellar comet 3I/Atlas, just as it prepares for its closest approach to Earth on December 19, 2025. This marks a monumental milestone in the study of interstellar objects, as 3I/Atlas, which was first discovered in late June and identified as the third known interstellar object by July, speeds toward the edge of our solar system. The comet, a massive icy snowball with a tail of gas and dust, is zooming through our corner of space at an astonishing speed of 130,000 miles per hour, 210,000 kilometers per hour. Since its discovery, 3I/Atlas has intrigued astronomers and space agencies around the world due to its origin outside our solar system and its remarkable trajectory. The comet has already made close passes of Mars and the Sun, igniting significant interest among scientists studying its structure, composition, and behavior. It is now heading towards Earth for its closest encounter on December 19, 2025. At this time, 3I/Atlas will be about 170 million miles, 270 million kilometers, from Earth, roughly twice the distance between Earth and the Sun. This close approach has sparked a flurry of activity among NASA and ESA, who are using their cutting-edge space telescopes and spacecraft to capture as many high-resolution images of the comet as possible before it departs our solar system for good. The significance of the December 19th encounter, while 3I/Atlas has already made some notable passes near Mars and the Sun, its December 19th encounter with Earth marks a key event in its journey. Although this close approach will still be a considerable distance from our planet, it will allow scientists to gather unprecedented details about this interstellar object. Interstellar comets are a rare phenomenon, and 3I/Atlas has already captivated researchers because it is not from our own solar system. Studying it as it makes its way through our solar system can provide new insights into the materials and conditions present in other star systems. The fact that 3I/Atlas is an interstellar object means that it was not formed in the Sun's neighborhood. Instead, it has traveled across interstellar space before entering our solar system. This is an exciting discovery because it gives astronomers a direct opportunity to study materials that may not exist in our own solar system. Such objects can tell us a great deal about the early stages of star and planet formation, shedding light on the processes that occurred in other parts of our galaxy. Close-up observations. Hubble's high-resolution imaging. Both NASA and ESA have been working around the clock to capture high-resolution images of 3I/Atlas, using some of the most advanced space telescopes available. One of the most significant recent images was taken by NASA's Hubble Space Telescope on November 30, 2025, when it was positioned about 178 million miles, 286 million kilometers, from the comet. This was considerably closer than Hubble's initial image taken in late July, which showed little more than a blue blur. The new image, however, reveals much more detail. In the November 30th Hubble image, 3I/Atlas is seen as a glowing white dot at the center of the frame. This dot represents the comet's nucleus, its solid core, as well as its coma, the bright halo of gas and dust that surrounds it. The coma is formed when the comet approaches the Sun, causing the frozen gases inside it to sublimate. As the gas is pushed away by solar radiation, it forms a tail that stretches away from the Sun. In the Hubble image, this tail is not fully visible, but you can see the distinct coma around the comet's nucleus. The coma is typically brightest on the side facing the Sun, because that is where the most sublimation occurs. Solar radiation heats up the comet's surface, causing jets of gas and dust to be expelled from the warm side. This sublimated material is what forms the bright coma, which can sometimes be so large it extends millions of miles into space. The dynamic nature of comets, as 3I/Atlas continues its journey through the inner solar system. Its activity has increased dramatically. Like most comets, it has grown brighter as it approaches the Sun, which causes the ice and dust within it to vaporize and form the coma and tail. The recent images from Hubble reveal that 3I/Atlas is in an active phase, as jets of gas and dust continue to shoot out from its surface. The comet is likely experiencing increased sublimation of its volatile ices as it moves closer to the Sun. This process of sublimation is one of the defining characteristics of comets. As the Sun heats a comet, the volatile ices, which could include water, carbon dioxide, and other compounds, turn directly into gas without first becoming liquid. This gas then forms the coma, which is often visible in telescopic images. The sublimation process also produces the comet's characteristic tail, which always points away from the Sun due to the solar wind. The tail can stretch millions of kilometers and is one of the most dramatic features of any comet. However, what sets 3I/Atlas apart from other comets is its interstellar origin. This means that the material inside it may differ from the typical makeup of comets found in our solar system. Scientists are eager to analyze the composition of 3I/Atlas's coma and nucleus to understand if it contains any materials that are rare or absent in our own solar system. These observations will help scientists understand how star systems, like our own, form and evolve. A valuable opportunity for science beyond its stunning visual appearance. The interstellar origin of 3I/Atlas presents a unique scientific opportunity. It is the third known interstellar object detected in our solar system, following the discovery of Oumuamua in 2017 and the comet 2I/Borisov in 2019. Each of these objects has provided valuable data about the composition of material from other star systems, which can be compared to the objects in our own solar system to see what similarities and differences exist. Given the scarcity of interstellar objects, scientists view 3I/Atlas as a rare and valuable target for research. Because it is a relatively bright object compared to other interstellar visitors, it allows for detailed study with a range of scientific instruments. These observations could help scientists improve models of how matter behaves in the space between stars, offering clues about the environment of other star systems and how they compare to our own. In addition to providing insights into the makeup of distant star systems, studying 3I/Atlas could also yield clues about the early solar system. Some researchers speculate that interstellar objects like 3I/Atlas could have played a role in seeding the solar system with certain types of material, such as organic molecules that may have contributed to the origins of life on Earth. Looking ahead, the future of interstellar exploration, as we await the comet's closest approach on December 19th, the work of NASA and ESA continues. These agencies are collecting as much data as possible to make sense of this extraordinary object. Once 3I/Atlas passes through the inner solar system and begins its journey out again, its speed and trajectory will make it difficult to study in such detail again. Therefore, the next few weeks present a unique window for scientists to understand this object before it becomes too distant for observation. The study of interstellar objects has only just begun, and with each new discovery, we are learning more about the vastness of our galaxy and the objects that travel through it. 3I/Atlas, as the latest celebrity comet, is a testament to humanity's growing ability to explore the cosmos and gather data on objects that come from beyond our solar system. As space exploration continues to advance, we can expect more such interstellar visitors to enter our solar system, bringing with them invaluable scientific insights into the nature of our universe.